Okay, so problem number 17 is given as this. See, this type of problem is very important for exam. Okay, so here are some equipotential surfaces are given like this. Okay, these are the equipotential surfaces. Okay, this is 10 volt, 20 volt, 30 volt. This is 10 centimeter, 20 centimeter, 30 centimeter, like this. Okay, so see here, one thing is two things are very clear. First, always the electric field is perpendicular to the equipotential surfaces, right? Okay, we know this thing. Okay, so electric field will be like this, from higher to the lower potential, and it will be perpendicular to the equipotential surfaces. So this will be the direction of electric field. Now it is given here 30 degree, so this angle is 60 degree. Now see, this is 10 centimeters, so this is 20 centimeter. So we can tell that this length is 10 centimeter, right? Okay, so fine, so this length is 10 centimeter. Okay, so see, in every 10 centimeter the potential or the voltage is being changed by 10 volts. Okay, so the rate of change of voltage with distance is same. Okay, fine, the rate of change of voltage with distance is the same at all points, right? See, in every 10 centimeter the change in voltage is 10 volt in the first case, in the second case, so in the third case, and it will go on. Okay, so the electric field is uniform, because electric field, the magnitude of electric field is basically dV/dr. Okay, the gradient of the voltage, electrostatic potential, right? So it will be, see, let this be the perpendicular distance. Okay, call it dr. Okay, between the perpendicular distance between the equipotential surfaces we must consider. So here, see the triangle. Okay, so from here we can tell that cos 60 will be dr by hypotenuse, that is 10 centimeter. So from this triangle we can tell 10 centimeter means 10 into 10 to the power minus 2. Okay, so it will be 10 into dr. Okay, if we consider it in meters, so it is half 10 into dr, so dr becomes 20, 1 by 20. Okay, clear? So you see, now magnitude of electric field will be dV by dr, that is, what is dV? The change of the potential between two equipotential surfaces is 20 minus 10, you can take. Okay, if you consider the second case, then 30 minus 20, like this. Still is the same at all intervals. Okay, so it is 10 volt. Okay, so call it 20 minus 10, and dr is 1 by 20. So the magnitude of electric field will be 10 into 20, that is 200 volt per meter. Okay, now see the second problem. Okay, the second problem is here, these are the spherical or circular if you consider two dimension uh, equipotential surfaces. Okay, now see the equipotential surfaces. Here is this 60 volt, this 30 volt, this 20 volt. Okay, so this is 10 centimeter, this is 20, and this one is 30. So here the rate of change of voltage with distance is not uniform. Here in the first case, for the first 10 centimeter distance, the potential changes by 30 volt. The second case, for a distance of 10 centimeter, it is only changed by 10 volt. Okay, so here the electric field is not uniform. Okay, so how to do it in this case? Okay, so that means at every point electric field will be different, right? Not like the first problem that at every point electric field is the same, that is 200 volt per meter. Okay, so it was a bit easier. The second one is a bit tricky. So it is, see, you see the distance and the voltage in the first case, say 60 into 10 centimeter, it is 10 by 100. Okay, so it is 6. Okay, the second case, the distance becomes 20 and voltage becomes 30. Okay, again it's 6. The third case, it is coming out to be 20 into 30 by 100. Okay, so it is 6 again. So you see the voltage V and the distance R. Okay, at any point, if I consider this may be the point or this may be the point, at any point the voltage V and the distance R, okay, from the center, okay, their product will be the constant, same. Okay, the voltage V at any point and the product R, okay, will be constant. Okay, not the electric field will be constant here. It will not be uniform, it will be non-uniform, but the product of V and R is constant. So V and R is the constant value is 6. So it is 6. So V is 6 by R. So magnitude of electric field here is dV by dr. That is, this becomes minus 6 by r square. I am taking the magnitude only. So I am taking 6 by r square. Okay. This will be the answer. Alright. You can also write like this, minus dvdr, then you will write minus 6 by r square. Okay, I have taken the magnitude only. Okay, so E will be inversely proportional to r square, as V is inversely proportional to r. Okay, now let us do problem number 8, that is equation of lines of force of a dipole. But before doing this, before doing this, we must know one thing, that uh, radial and transverse direction. Okay, we must know this mathematical tool. We will not go into detail, we will just discuss simply that what is radial and transverse direction. It's important to derive the lines of force of a dipole. See, say this is position vector r of a point, and this is r plus dr. So for a neighboring point, the position vector is say r plus dr. Okay, now let this be theta, this angle, and this angle be d theta. Okay, so see, I can always have this length, I can tell this length to be r d theta. Okay, fine. Okay, now first let us define the radial direction. The radial direction is this, along the radius vector r hat, and the transverse direction is perpendicular to r hat, that is theta hat, in this direction. Okay, this is the transverse direction, theta hat. Okay, now you see, I can write this as dr vector, right? Okay, this vector is dr. Okay, say triangle of vector addition r plus dr. Okay, the resultant. Okay, now we can say, if we complete, see, this is r d theta, so this much length can be assumed to be dr. Okay, this much length is r, this much length is r. Okay, fine. So this much I can assume to be dr magnitude. Okay, the length which is the length by which this is greater than this one. Okay, this is dr. Okay, fine. Okay, now if I complete this parallelogram, now what I can say, if I complete this one, this parallelogram, see, this is my parallelogram, see, this is my parallelogram. Okay, fine. Then this one. Okay, see, dr is the diagonal. Okay, clear? So I am getting one vector here and another vector here, so the resultant of these two vectors will be dr, the diagonal. Okay, fine. So if this is dr, I can also say this is also dr, right? This is also dr, isn't it? Clear? So you see, this vector can be written as r hat dr, this vector. Okay, here this is r hat dr, and this vector, okay, this can be written as, the magnitude is r d theta and the direction is theta hat, r d theta theta hat. Okay, the resultant of these two vectors is dr. From this parallelogram we have discussed, right? It is dr. Okay, now you see, we have to discuss one analogy. See, we know that previously we know dr was I hat dx plus j hat dy. Okay, so this is a very familiar relation. Okay, so from here we can say that tan theta, okay, this is a slope of tangent, okay, is dy by dx. Okay. Again, we know for lines of force, the intensity is along the tangent to the lines of force. Okay. So tan theta can also be written as Ey by Ex. Okay. This we have discussed earlier. Okay, in the previous classes. Okay. Now you see the analogy here. Here we got dr as in terms of this one we have written in terms of x and y direction. Okay, I had j had, but in terms of radial and cross radial, that means radial and transverse direction, we were writing it as r hat dr plus theta hat r d theta. Okay, so you consider the analogy here. See, this component is analogous to this component. Okay, and this component is analogous to this component. So here also what we can write tan theta as, it was dy by dx, so it will be r d theta by dr. Okay, now you see, so tan theta in this case we can also write it as, it was ey by ex. So here in terms of transverse and radial direction, we will write it as e theta by er. Okay, transverse and radial component of electric field. Okay, the slope of tangent will be this, because the intensity is along tangent at a point on the lines of force. ঠিক আছে? So as it is along the tangent on a line of force, it will be e theta by er tan theta. So it is equals r d theta by dr. Okay, so in order to derive the lines of force of a dipole, we must consider this relation. Okay, fine. Previously we discussed this one, and now just from analogy we will discuss this relation. ঠিক আছে, with the help of this relation we can derive it. Okay, why we need to consider this radial and transverse direction? See, this one also is known to you very clearly. See, for a dipole, we knew that electric field at a point, at any arbitrary point, when we have measured this is r, this is theta. See, we considered one axial field E1. See, this is in the radial direction, isn't it, r hat, and we consider one equatorial field, that is E2. Okay, it is in the transverse direction, theta hat, isn't it? Okay, so E1 is basically the radial component ER, and E2 is basically the transverse component E theta of the net electric field E at a point due to a dipole, isn't it? Okay, so what we got, we already knew this one from electrostatics. ER is 1 by 4 pi epsilon naught 2p by r cube, no, 2p cos theta by r cube, and E theta is 1 by 4 pi epsilon naught p sin theta by r cube. Okay, now from our known relation we will just put it here, E theta by er. So r d theta by dr is E theta by er, so this thing gone, p by r cube gone, so it will be sin theta by 2 cos theta, isn't it? Okay, so see what we can write here. Put cos theta here, cos theta d theta by sin theta. Okay, and here we get, put a 2 also here, dr by r, isn't it? So what we can write it as, cos theta d theta is d of sin theta by sin theta, so it is dr by r. Okay, now integrate. Let us add one integration constant as ln c. So what will happen to ln? This is ln sine theta. Okay, this is ln r plus ln c. Okay, so we get, this is ln sine square theta is ln cr. Okay, so r equals 1 by c sine square theta. Call it k sine square theta. Okay, fine. Okay, so this is the equation of lines of force r equals k sine square theta for a dipole. Alright, clear? See, you saw this one, na? Plus minus. Okay, so the lines of force, they are like this. So these curves, okay, actually these curves, it's like this, na? Okay, you have seen this figure number of times. So these curves actually follows this equation. Okay, this is the r versus theta relation. Okay, sometimes students think that these are parabola. Okay, these lines of force are parabolic or hyperbolic. Hyperbolic, they don't think parabolic. Okay, but they are not. Okay, so this is the equation of line of force. Now let us consider one more problem here. Problem number 4, the second one in problem number 4. Two charges are given. This one is a NCERT problem. Okay, the charges are given in an external electric field. What is the energy of the system? See, in order to calculate the energy, suppose the potential at this point is V1 and this point is V2. So the energy of Q1 due to the external field is Q1 V1 plus Q2 V2 for the second charge. These are the self energies. Now there are interaction energies. So these are basically due to the external field, these two terms. Okay, now due to the self interaction, there is another energy. It is KQ1. K means 1 by 4 pi epsilon naught by the distance between them is d, say, by d. Okay, this is the self energy. Okay, potential energy. So this is the total. So this is the internal energy of the system. Okay, so this is the total energy of the system, of this system placed in the external electric field. Okay, suppose there is one NCERT problem that one charge is given as minus 2 microcoulomb and Q2 is given as 7 microcoulomb and D, the distance between them, is 18 centimeter. Okay, now they are placed in the external electric field is given as A E equals A by R square. Okay, where A is given as 9 into 10 to the power 5, like this. Okay, so it will be E means minus dV dr. So it is A dr by R square. We integrate, we get minus V is minus A by R. So V is coming out to be A by R. Okay, fine. Now it is given like this, that this charge minus 2 is at a point minus 900. this is the midpoint origin, and this 7 microcoulomb is placed at a point plus 900. So the distance between it is 18 centimeter. Okay, so what is the energy? Okay, so energy will be from the formula, say U will be Q1 V1. Okay, so it is minus 2 Q1 into V1. V1 is A by R, that is A by, it is 9, R is 9. Okay, this is V na, so it is 9, that is 0.09. Okay, minus 0.09. Okay, now plus Q2 V2. The Q2 is 7 into A by, so these are microcoulomb, right? Okay, so we'll have to 10 multiply 10 to the power minus 6. Okay, so it is A by R. R is plus 0.09. Okay, Q1 V1 plus Q2 V2, so into 10 to the power minus 6, take it common for the microcoulomb case. And the next is K is 9 into 10 to the power 9. Okay, Q1 Q2, that is 7 into minus 2 by distance is 0.18. Okay, so just calculate what will be U. Say 2 plus 7 is 9, and into A is 9 into 10 to the power 5 by, here it is 9 into 10 to the power minus 2 into 10 to the power minus 6. Okay, plus, sorry, minus it will be 10 to the power 7, 9, it will be 0.02, so 2 and 0.01, so it will be 7 into 10 to the power 9 into, oh, microcoulomb means there will be a 10 to the power minus 12, 10 to the power minus 6 into 10 to the power minus 6. Okay, so it will be 10 square when it will go up, and there will be 10 to the power minus 12, so it will come out to be 9 and 9 gone, so it will be 9 into 7, 10. Okay, minus this will be 0.7. Alright, sorry, I have given it a minus here. This is just the distance. Okay, R is not the coordinate. Okay, it's not the X, it's just the R is the distance. Okay, it's not the coordinate. Okay, so it will not be, if it is coordinate then we have to put minus 9, but it is just the distance, so we have to close 0.09 here, so it will be 7 minus 2, that is 5. It will be 5. Okay, So 9 and 9 gone, so it will be 5 into 10 minus 0.7. Okay, that is 50 minus 0.7, so it will come out to be 49.3 joule. Okay, so this one is the problem. Alright, so এই প্রবলেমটাতে এইটা খেয়াল রাখতে হবে, কিন্তু নাহলে ভুল হবে যে এখানে এই ইলেকট্রিক ফিল্ডের ভ্যারিয়েশনটা যে দিয়েছে আর এর সাথে, এই আরটা হচ্ছে ডিস্টেন্স ফ্রম অরিজিন, ঠিক আছে, অরিজিনের থেকে ডিস্টেন্সের সাথে দিয়েছে। ওকে, ক্লিয়ার। কিন্তু এটা যদি কোঅর্ডিনেটের সাথে দিত, মানে সে বললো ভ্যারিজ উইথ এক্স কোঅর্ডিনেট দিয়ে দিল এ বাই এক্স স্কোয়ার, তাহলে কিন্তু তখন এটা যে কোঅর্ডিনেট এ বাই এক্স আসতো, তখন কিন্তু এখানে -9 পুট করতে হতো আর +9। এখানে যেহেতু জাস্ট ডিস্টেন্সের সাথে দিয়েছে, তাই এখানে দুটোই শুধু ডিস্টেন্স পুট করতে হলো। ক্লিয়ার? ওকে, কোঅর্ডিনেট পুট করতে হলো না, এটা কিন্তু খেয়াল রাখতে হবে। ওকে, ফাইন।